All right. Pick up your colored pens and let's mark up our work to see how we're doing with proving lines parallel. So, start out with the given. Where'd you go from there? What was your next step? All right, Team G. Where's Team G? Team G, all three of you. Kadir, what was your next step? And what was the reason? Okay. Stephanie? Okay. And what did you do, Ziamar? Okay. So I went here. Angle 1 is congruent to angle 3 because of the alternate interior angles congruence theorem. It doesn't matter, necessarily. So let me ask a different question. Let's go backwards. Here is the proof statement. What was your statement right before it? What was your statement right before it? And let's go to Team B. Everybody. Team B, Stephanie in the Valley. What'd you put for your second to last statement?
I put angle 1 is congruent to angle 3.
Okay. Well, what was the reason for that?
Substitution.
Substitution. And what did you put? Okay. So it should have been something like angle 2 is congruent to angle 3 because of the transitive property of equality. Because the whole point is to get angle 2 and angle 3 to be congruent to prove that the lines are parallel. So, here is my full proof. You could have flip-flopped statement number 2 and number 3. That whole team seemed to think that statement number 3 should have come first. That's fine. But the idea is the path of logic. And so, what you needed to recognize was, and this is what we spoke about last time, this being the key. What fact would have to come out to prove that P was parallel to R? So we need P parallel to R, so we need this congruent to that to prove that. These are the only two labeled angles. So we need to prove that those two are congruent because we know this. We know that there's a converse of the alternate interior angles congruence theorem. The converse says that if they are congruent, then those two lines must be parallel. So figuring this out was a key that established the path of logic. Any comments or questions? Comments or questions? So Stephanie, you said that your second to last step was angle 1 is congruent to angle 3. But that does not prove that P is parallel to R. So how did you get from there to the final statement? Was there another statement in there, or you thought that that proved it? So my interpretation is that you thought that that proved it. Okay? But the problem is this, that the relationship that you're looking at has nothing to do with line R. It has to do with lines N and M. That's one thing that makes these pictures so confusing, is that you look at this and you're thinking, well, wait, these are parallel, these look parallel, and then you get confused on what's what. You need to use your hand or a piece of paper to hide parts of the picture so you can focus on what you need to focus on. Okay? So I'm not picking on Stephanie in any way. I'm sure part of her proof was very valid. But you needed to show that angle 2, you needed to show that angle 2 was congruent to angle 3 to prove that P was parallel to R. Extol and then Kadir.
Even though we're using congruent symbols, should we still put equality?
You're right, this should have been congruence. Absolutely. You're talking about this right here? Absolutely correct. I made a mistake. Transitive property of congruence. This is not equality, this is congruence, and I should have put congruence. Thank you for correcting me, Extol. Kadir. Same thing? Okay, I apologize. So thank you for pointing that out. That's a very good catch. And yeah, that's a detail, but that's an important detail. There's a difference. Any comments, questions, or concerns on today's warm-up? Okay, let's push that pause button. So, today's lesson, 3.5, writing and graphing equations of lines. As I already alluded to, we will be taking everything we learned last year and putting it all together in one lesson and kind of putting it into the context of what we've been doing so far this year. So, our objectives are to graph lines and to write their equations in two different forms, slope-intercept and point-slope. I realize now that I made a small mistake. I put standard form in here and I had intended to put point-slope. So I apologize for that. I will refresh your memory about point-slope when we get to the first question. So, but remember that these are different forms of the same thing. You remember the analogy I used last year is money. You know, 4 quarters, 10 dimes. Two different ways to express the same value. It's the same thing with a linear equation. If it's in slope-intercept form, you could have it in standard form and it could be the same equation. Just looks different. So let's jump in with the different types of material we're going to see. So we'll start with writing an equation. So write an equation of each line in the given form. So we're given some information about the line, about the equation, and the form that we would like it in. So I neglected during the notes to refresh you about what point-slope form was. So here's what it was. Y minus y1 equals the slope, m, times the quantity x minus x1. And x1 and y1 were the coordinates of a point on the line. And you might remember that point-slope form had many, many different versions, because you can take any point from the line. So, take the information that we have and plug it into the form. If we're missing any pieces of information, we have to find the pieces of information. In this case, we're given the slope, 6, and that's going to go right here. And we're given an ordered pair right here, and that's going to go here and here. So we have all the information we need, so just go ahead and write the equation of the line and simplify anything that needs simplification. So it's going to be y, and now we do minus y1. Well, that's minus -4, bless you. But you should remember that we in advanced math do not write minus a negative. What do we write instead? Zumar? Yeah, so we write that as y plus 4. Equals the slope of 6 times x minus 3. So that's a positive number, so we'll just put minus 3. And so now we have written an equation of the line represented by that information. Does anyone have any questions on how we put all of this together? Not so difficult. But what about when we're only given points? So part B, we would like the equation of the line in slope-intercept form that of the line that passes through -1, 0, and 1, 2. You'll recall that slope-intercept form is y equals mx plus b. The y and the x stay y and x. We have to supply the m and we have to supply the b. So we need y equals something x plus something. We have to fill those pieces of information in, which means we need the slope and the y-intercept. We don't have either of them. So we have to figure out how to get the slope and the y-intercept just from this information. Anyone recall how we do that? Oh, a few people. Nathaniel? Okay, so we use the slope formula, beautifully said, with the 2 points. This is x1, y1, x2, y2. And use the slope formula. M equals y2 minus y1 over x2 minus x1. And we get 2 over 2. Slope is 1. And so we get y equals 1x plus something. How do we get the y-intercept? How do we get this missing piece right here? Kamoy? Very good. That was beautifully stated. Do you remember how hard this was for you guys last year? It was incredibly challenging to you last year, and yet she was able to remember from almost exactly a year ago exactly what to do. Yeah, we have an x and a y here, and we have an x and a y right here. So plug them in and solve for b. So 2 equals 1, that's the slope, times x, which is 1, plus b. Solve for b. What is it? Kayla? You agree, John? Yeah, it's 1. And so we have now written an equation of the line that passes through those 2 points. Y equals x plus 1. Anyone have any comments or questions on how we did that? So there were 2 steps. Find the slope, find the y-intercept, plug them in. Any questions about that? Any concerns? Okay, let's see how you do on your own. Oops, excuse me. Checkpoint number 1. Write the equation of each line in the given form. You've got 2 different equations to write. You've got 2 equations. You've got 3 minutes. If there's any concerns of any kind, please let me know. I will come help you. You can also rely on your teammates to help you as well. how we're doing with writing equations. Part A. Team B. Where's Team B? Team B. Tell me what you got for Part A. Valerie, tell me what you got. Okay, what'd you get?
Y equals 6.
Okay, so we have a disagreement. Anyone want to chime in with their answer to help alleviate the conflict? Alexandra and then Eric. So you agree with Stephanie. What do you think?
Y equals 6.
We seem to have more support for y equals 6, and it is y equals 6. If you did not get that, in a moment you'll go backwards and see if you can figure out where you went wrong. Part B. What did you get? Let's go with Team E. Where's Team E? Right here. Start and going across. What'd you get?
Y plus 3 equals 0 and x minus 2.
Okay.
Y plus 3 equals 0 times x minus 2.
Okay. Okay. I will actually accept all of them. I wrote it like this, y equals 2, but there's quite a few different ways to write it, so let me write this down before you mark yours correct or incorrect. So I would accept, what was yours, Diana?
Y plus 3 equals 0 times x minus 2.
And so you use that point, right? Okay, I'll take that. Absolutely. Yours was different. What was yours? Y minus 2 equals 0. I will absolutely take that, and that's actually how I got mine, because I added 2 to both sides, and I got y equals 2. But absolutely. John, you said yours was the same. Anyone have a different one that they think maybe is correct? Come on. Okay, so you put in the x minus 1 right there. Very good. I'll take that as well. Any comments, questions, or concerns about writing an equation of a line? Give me a thumbs up if you got both of them right. Okay, some of us? Good. Put your thumbs down. Are there any comments or questions? Okay, so let's shift to graphing. So, this is part A of example 2, graph the line. So we need a coordinate grid. And then we need a quick refresher. What form is this equation in? What form is it in? Stephen? Good. So with slope-intercept form, what's our starting point for a graph? What's the starting point? Kadir? And what is it in this case? Yeah, this is our starting point right here. We always need a starting point. So we put a point right there. And then what do we do next? How do we get from that to an actual line? Just 2 people remember how to do it? Okay, hopefully you'll remember in a moment. Go ahead, Valerie. Very good. We use the slope, rise over run. Up 1 over 2, put a point. Up 1 over 2, put a point. Or you can go down 1 left 2, put a point. As long as you follow the path. And then you connect the dots and have a line go all the way through them. We are in geometry, so we're using rulers for things. Precision is important. Anyone have any comments, questions on how we got the line from the equation? Any concerns of any kind? Do you remember how hard this was last year? Maybe, maybe not. Well, I was right there when you were doing it, and it was hard for you. Now, not so much. Maybe this one wasn't so hard. Yes, John?
This one was good. I thought this was the easy part.
You thought this was the easy part? Good. All right. So, then let's go to the hard part. Graphing from point-slope form. Again, we need a grid. Just give you a moment to set up a grid. But we need a starting point. So that's the common theme. Excuse me, that's the common thread. We always need a starting point. But what's our starting point coming from point-slope form? Sharik?
The coordinates hidden in the point slope form.
Good, I love the way you said that. And so in this case, what is it?
It's the point would be -4, 3.
Okay, and that's the hard part. And so this is a little bit harder. So the ordered pair is actually -4, +3. So remember that it's always the opposite of this and the opposite of that. So it's -4, 3, and that's our starting point. So -4, 1, 2, 3, 4, 3, 1, 2, 3. And then we do exactly what Valerie explained in slope-intercept form. We use the slope. This time it's -2 or -2/1. Down 2/1, put a point. Down 2/1, put a point. Or go up 2 to the left, put a point. And then connect the dots. Anyone have any comments or questions on how we graphed from the point-slope form? Again, getting from here and here to here is the key. Any questions? Any questions now that you've seen both slope-intercept form and point-slope form? Any questions at all? Okay. So now, here's where I say partially that I dropped the ball and partially you dropped the ball last year. Is how do we graph something that looks like this? John made a reference to the easy stuff, and I guess I made an assumption that I thought this was the ridiculously easy stuff. And then unfortunately, we had a bunch of people last year butcher this. Go ahead.
Oh, I was going to.
Go ahead. Say, what do you think?
So from top of point, the line is set -3, and there's no slope, so it's just a horizontal line.
That's right. That was a great description. And I love how you said that that's the y-intercept. That's where students got confused because they saw y equals -3, and they see the y, and they think, oh, well, the y-axis is a vertical line, so that must mean I draw a vertical line at -3. But that's not what is going on here. What he said is exactly right, that y equals -3 means that is the y-intercept. Would it make sense to draw a line straight through this way? No. So we draw a horizontal line through it going this way. And so that is the graph of y equals -3. If we had a different equation, x equals 4, that's the x-intercept. And so we would put a point at x is 4, and then draw a vertical line through that. Any comments or questions on horizontal, vertical lines? This is going to be important in the near future. Any comments or questions? So now we've seen 3 different graphs. Any comments or questions? Okay, checkpoint number 2. I want you to draw one grid and graph both lines on the same grid. Got 3 minutes. Give me a thumbs up if you were able to graph both already. Good, so I'm going to reveal the picture and you compare. Excuse me, sorry. And so that is what your picture should have looked like. Give me a thumbs up if you got it right. Outstanding. Put your thumbs down. So we've built a little bit. We talked first about writing equations, and then we graphed them. And now we finished up last year when we studied this with parallel and perpendicular lines. And so we're going to finish today with that. That's really what we've been leading up to, because that's what we've been studying for the past week, week and a half. Parallel and perpendicular lines. And so you're going to see and hear some things that you heard last year. This was very challenging last year, but my hope is that it will be a little bit more digestible this year. So we're going to do two different examples, one with parallel and one with perpendicular. Write an equation of the line passing through -1, 1 that is parallel to the line y equals 2x minus 3. Now, I've taught this idea for a long time, and I understand children's reactions. You get very lost with this being here. Because I'm asking you to write an equation, and yet there's an equation right here. And you're like, well, what do you mean write an equation? There's an equation right there. Write an equation that's parallel to that? Well, isn't that it right there? Do I just take this and put it in there and just change that? Like, what do I do? And so what I tried to do last year, and I'm going to do again this year, is try and help you see the purpose of this being here. That has a very specific purpose. That is actually to give you one piece of information. That is there to give you one piece of information and one piece of information only. Let me rewind for a second. For every line that we graphed or we wrote, what was one piece of information that we had to have no matter what form we put it in? A lot of people see it now. Valerie? Needed the slope. Here, we were given the slope. Here, we had to calculate the slope. But no matter what, we needed the slope. Here, we were given the slope, and then we had to calculate it. Here, we can see the slope right here, and we used it to form the line. Same thing with this one. So, where is the slope? I only have 1 point, so I can't use the slope formula. Where is the slope? That's what this is supposed to tell us. What is it? Stephanie? It's 2. Are you certain? Yeah, because you take this with this word right here, and you know that two lines that have the same slope are parallel. So if you have two parallel lines, they will have the same slope. And so really what we are being asked to do is this. This is a very fancy way of saying write an equation of a line passing through point -1, 1 when n is 2. That's really what that says. It's just your job to get from here to here. That's your job. So let me rewrite this a little bit differently. So now we know that this means m equals 2, and we have this point. Now let's write the equation. What form is really easy to use when you have a point and the slope? John? Point slope form. It's right there in the name of it. Point slope. Point slope. So y minus 1 equals 2 times x minus -1. That means we put +1, just like Ziomara taught us earlier. And so we get this equation in point slope form. Does anyone have any questions on how we did that? What if I now wanted to take this equation and write it into slope-intercept form? What could I do now? What could we do now to write it in slope-intercept form? Kadir, what could we do? Yeah, distribute. Distribute, distribute. You get y minus 1 equals 2x plus 2. Is that slope-intercept form?
No.
Not yet. What do I need to do finally to get it in slope-intercept form? Nathaniel? Good. I love the way you said that. Addition property of equality. Add 1 to both sides. Y equals 2x plus 3. Now we have the same equation written in two different forms. We've got it in point-slope form, and we have it in slope-intercept form. And they both mean the same thing. That's 4/4, that's 10 dimes. It's the same thing. Anyone have any questions on how we did that? The whole purpose of this example, though, was to illustrate parallel plus this tells you this right here. Any questions about that? So let's build from there to the idea of perpendicular. Write an equation of the line J passing through the points 2, 3 that is perpendicular to line K with the equation y equals negative 2x plus 2. Sounds very involved and confusing. But as I just explained in the previous example, all of this is a fancy way of saying m equals something. M equals, and now it's our job to interpret this. If we use the word perpendicular and we use this equation, we should be able to figure out what m is. So think about what you think m is and give me a thumbs up when you've got it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Kalasia, what do you think it is? Okay, Dayanara, what do you think it is? 1 over 2. Okay, so that's very different. So we have a disagreement. Alexandra, what did you think it was? 1/2. 1/2 is fine. 1 over 2. Stephen? 1 over 2. Where did the 1 over 2 come from? I don't understand. Kamoy? Well, the reciprocal of negative 2 is negative 1/2. So where does the positive 1/2 come from? Yeah, that's right. Perpendicular slopes will be opposite reciprocal. So yeah, they were exactly right. You take this and you flip it and flip the sign, and so the slope is 1/2. And so now you have this point and the slope, write an equation of the line. You've got point-slope form is perfect. Y minus 3 equals 1/2 times x minus 2. If you need it in slope-intercept form, distribute, and then add 3 to both sides. Y minus 3 equals 1/2 x minus 1. Add 3, add 3. Y equals 1/2 x plus 2. And so now you have the equation of the line perpendicular to the original line, but that's passing through 2, 3, and we've got it in two different forms. Does anyone have any questions on how we went about this? Any concerns of any kind? Okay. Checkpoint number 3. Now I want to clarify what I mean by the instructions, so let's read this together. Write an equation of the line that passes through the point 1, 5 and is parallel to the line 1 equals 3x minus 5. Graph both lines in the same coordinate grid. What I mean by graph both lines is find me a new line and then graph the new line and the original line both in the same grade. Okay? If you're confused, let me know and I will come help you. Any questions? So now you are finding the equation of a line and graphing. So you've got 3 minutes on the clock. If it ends up not being enough time, I will extend it. That's no problem whatsoever. All right. Let's see how you did. This was the equation of the new line, y equals 3x plus 2. And you graph both of them, and this is what your picture should have looked like. The original equation has a y-intercept of -5. The new one has a y-intercept of 2. Same slope, parallel lines. Anyone have any comments or questions?
If I put it in the slope of the curve.
Yeah, I didn't specify, so yeah, that's fine. You have the same picture? Good. That's how we know it's the same thing. Any other comments, questions? Any concerns of any kind from what we did today? Okay. Draw a line across your paper. Your homework is page 176, numbers 4 through 34 even. And make sure you write even, otherwise you're going to end up doing a lot. And then 46 through 51 is all. So 4 through 34 even, and 46 through 51 all. That's a total of 22 questions. Read the next section, the at-home tutor 3.6. You have a quiz tomorrow. And that will be on 3.1 to 3.3 only. So make sure you know what's in